Hello everyone, today I want to explain my homework 7, homework 3. Write a render diagram and HCL language to control two screens that can be shown 4 digits via touch screen by using two screens. This positioning will follow the structure outlined here. We will start with the project objectives, then move to the hardware and the software used, followed by a detailed look at the PLC tag configuration, the render diagram program itself, the HTML screen design, a system demonstration, and finally a calculation. For this experiment, I used a Siemens PLC with S7-1200 and two Siemens touchscreen HTML. The communication and the programming were done using a intent cable. The software environment is Siemens TIA Patrol, which is the standard tool for programming Siemens PLC and configuring HMI as I primarily used render diagram for the main control logical. The slide shows the PLC tags I configured. Tags are like nicknames for the PLC's memory address, making the program much easier to understand and maintain. I defined several key tags: HM start, HM stop, and HM result, which are below variable linked to the HMI buttons. I also have a 16-bit integer variable called date1 to store the 4-digit number we want to display, and an internal memory bit tag3 for the start to stop latching logical. Now let's look at the render diagram program. Starting with network 1. This is a classical start to stop latching circuit. When the HMI start button is pressed, it energizes the internal memory bit tag 3. A further contact from tag 3 then keeps the circuit closed even after the start button is released. The stop button breaks this circuit, turning tag 3 off. This is fundamental for model or system control. Moving on to network 2 and 3. Network 2 handles the counting function. As long as tag 3 is on, the system is running. 1 Hz clock pulse from the PLC increments the date1 integer every second. This date1 variable holds our 4-digit number. Network 3 is the reset functions. When the reset button on the HMI is pressed, a move instruction sets the value of date1 back to 0, resetting our counter. For the HMI to interact with the PLC, we need to link HMI tags to PLC tags. This slide shows the HMI tag configuration Each button and display element on the HMI screen is associated with an HMI tag, which is then linked to the corresponding PLC tag we defined earlier, like that one, start, stop, and restart. This linking process is critical of the HMI to set commands to and receive data from the PLC. Now let's look at the HMI screens. This is screen 1, the control panel. It's a simple interface with 3 buttons: start, stop, and restart. As we saw in the tag linking, these buttons are directly connected to the HM start, HM stop, and the HM result tags in the PLC, allowing the user to control the system's operation. This is screen 2, the 4-digit display screen on the second HMI. The central element is a numerical input or output field linked to the date1 tag. This field continuously updates to show the correct value of the counter running in the PLC. It also has a back button to return to the control screen. This setup fulfills the requirement of using 2 screens for control and display. To summarize the system workflow, when the user presses start on the first HMI, the PLC starts counting, and the value is immediately displayed on the second HMI screen. The user can stop the count or reset it to 0 using the buttons on the first screen. The 2 HMI communicate with the single PLC to perform their respective roles, one for control and one for display, demonstrating a simple but effective distributed control system. Let's look at the video. In conclusion, I have successfully completed the assignment by designing and implementing a PLC program that controlling 2 HMI screens to display a 4-digit counter value. This project has significantly improved my understanding of PLC, HMI integration, and rendered logical programming. I would like to this That is all my homework. Thanks for listening. See you.